We're Denso Manufacturing, Tennessee. We're located in Maryville, Tennessee, and we manufacture automotive components. At our facilities, we manufacture starters, alternators, instrument clusters, and electronic components. Denso Manufacturing, Tennessee is located at the foothills of the Great Smoky Mountain National Park, and our core philosophy is to be a good corporate environmental citizen, and we're always looking at ways to minimize our impact to the environment. The types of coating processes that we have at our facilities entail powder coating, spray coating, brush coating, and dip coating. Our coating processes will fall into the miscellaneous plastic parts and products and the metal coating rule, which is the miscellaneous metal parts and products rule. And those will affect our operations in Maryville specifically. The types of pollution prevention activities that we use currently are HVLP guns, or high volume, low pressure guns. And we also use a lot of robotic applications for our spray techniques, so we can be very precise in where we apply our coatings. Some of the pollution prevention activities that we're currently investigating are reformulation, chemical substitution, add-on controls, and then administrative controls. In general, those are the four choices that industry has. And the first choice for us would be chemical substitution, where you'd eliminate your hazardous air pollutants from your coatings. And then the second choice would be reformulation, where you'd be HAP compliant and you'd still have your HAPs in your coatings, but you would be able to comply with the new regulations that are coming out. Chemical substitution for Denso is the elimination of 187 hazardous air pollutants, or HAPs, from our coating materials. Reformulation is taking our coating materials that we currently use and making them HAP compliant with the new coating regulations that are coming down the pipe. We have 3 facilities in Maryville, Tennessee. Each facility is a major source for HAPs. We're considered one area source for HAPs also. One of our facilities is a major source for VOCs. If we reduce our HAPs at all 3 of our facilities, we will still be a major source at one of our facilities. The Maryville campus received the ISO 14001 certification in December of 1997, and every year we go through a process of setting goals and objectives, and we evaluate our aspects and impacts as they relate to the environment. And every month and every year we will update our objectives and targets, or our goals and objectives, as they relate to our activities at our facility. Coating techniques typically used by industry are spray coating for plastics. Some facilities use plastic or powder coating, but we use spray coating currently. For the coating of metal products, most facilities use either spray, brush, or dip types of applications for coating of metal parts. In addition to that, you can also use powder coating. At our electronics facility, we utilize printed circuit boards when we make our engine control units and other electronic components. And most other facilities would not consider a printed circuit board a metal part, but it's our understanding that EPA has considered printed circuit boards a miscellaneous metal part because of their definition. So we take a functional coating and apply it to the board in different areas of the board. And just depending on the product, it depends on where the coating material is applied. And once it's applied on one side of the board, we'll apply it on the other side of the board, and then it'll go into the curing process. What we do is we insert our circuit board into this jig, close the top jig, take some coating material, and apply it with a brush in this area, and then it goes to a drying cell. We utilize dip, spray, and brush application for coating materials on our printed circuit boards. And the newest technology used by industry is to use robotic application of your coating materials. And the benefit of having the robot apply the material is it can be very precise in where you must apply the coating material. Therefore, you're minimizing the amount of material used, and you're not wasting as much material. Typically, because of the types of customer requirements that are involved, when we want to change our coating materials, first we must get customer approval. In addition to that, we have to meet all of the quality requirements of our customers. So this can take upwards of 3 years to just change our coating materials from the current ones in use. We're currently investigating powder coating, waterborne coating, solvent-borne coatings that are HAP compliant, and solvent-borne coatings that are HAP free to replace our plastic and metal coating materials. The biggest challenges that we face are meeting the customer requirements and our internal quality specifications for the coating materials and for the finished product that we will ship to our customer. The robotic application equipment is significantly more complex than a typical brush or dip application. Therefore, the programming time and the maintenance time required on these robots is significantly higher than the old style. Our facility is currently investigating the benefits and applicability of waterborne coatings in our processes. We have not decided whether we're going to use waterborne coatings or not yet. It is still under investigation. Challenges of using waterborne coatings is it is a significant paradigm shift in our current technique used. The capital equipment involved for waterborne coatings is significantly higher than solvent-borne, so we would have to replace all of our coating equipment at all of our facilities. So there's a tremendous capital expenditure involved with that. We're currently investigating UV coatings for some of our plastic parts. Again, the biggest challenges with UV coatings are the different capital equipment that we would have to purchase. Currently, we use solvent-borne coatings, so we would have to buy all new equipment, all new dryers, all new testing equipment. So there's a significant capital expenditure associated with that. The challenge for high solid coatings are, again, it's a different type of coating process, so there's a lot of training associated with it, different type of maintenance that would have to happen on the equipment, and it would be a slight process change to what we're currently doing. It's our understanding that high solids coating is powder coating application, and we're currently investigating powder coating application in some of our processes. Best management practices that we utilize involve keeping containers closed, making sure the day tanks have the lids on them, and when we change out materials, making sure that our waste containers are closed as well. We recycle our cleaning solvents in a few of our processes. The method that we use to recycle is we have a distillation unit on site where we'll be able to obtain the good solvent and reuse it and then send the distillation bottoms off-site for disposal. Because of our types of operations, we would choose a regenerative thermal oxidizer as an add-on control. The reason add-on controls are our third choice are due to the extremely high capital cost of the equipment and the extremely high operating costs of the equipment. The benefits of switching our coating materials are, number one, we'll be able to comply with the new coating regulations. Number two, we're going to minimize or reduce our emissions coming from our facility, which in turn will eliminate the need for Title V permits at 2 of our facilities. And number three, it's being a good corporate citizen to make those changes. One of Denso's core philosophies is a word called Kaizen, which is continuous improvement. And what that means is Denso's always finding a way to continually improve, and we're looking at these coating changes as an opportunity for continuous improvement. We're going to continue to improve the environment and continue to improve our operations.